In this video, we are going to talk about Newton's third law. So most of you know what Newton's third law is, or at least know the definition of it, or how the statement of Newton's third law goes by. So it simply says that if you apply a simple force F on the other object will also apply the same force on you, and these forces will be equal and in opposite direction. Or in another words, you can say that every action has its equal and opposite reaction. So if you represent this by F1 and this force by F2, then in vector format you can write F1 is equal to negative of F2. This negative sign representing that they are both in opposite direction. This law seems pretty simple, right? But there are quite a lot of misconceptions that I see in general life about this law. That is, people know what this law says, but they don't really quite understand it. And to demonstrate this, I'll show you some misconception and we'll all try to correct them. So the first misconception goes something like this. So let's say you are pushing a block on a frictionless surface. So let's say the surface is completely frictionless and you're applying a force F on the block, and the block is also applying a force on you. So let's say this force was 10 newtons, so block also applied a 10 newton of force on you. Now if this is the case, I can say that net force F net is equal to 0, isn't it? And if this F net is 0, then why should the body move? So let's figure out what actually is happening here. What are we missing? Because in normal life, you see, when you apply a force on a very small object, it usually moves, isn't it? So there must be something wrong with our understanding of Newton's third law. Alright, so Newton's third law says that every action has its equal and opposite reaction, but it also says that both action and reaction pair, they act on different bodies. That is, this force, action force, is on the box and this reaction force is on the body. So if you are interested in will the box move, what is your system? Your system is your box, and on the box there's only one force by me, right? And then you can find out the acceleration of the body at that time. That will be force by me divided by mass of the object. Now if I'm interested in myself, that what will happen to me, then my system is me, and on me, let's say my mass was capital M, and on this capital M there's a force on the left side by the box. So my acceleration, let's call it capital A, that will be equal to force of the box by my mass M. Hence both of us will have some acceleration. This guy will have acceleration A, I will have acceleration A, and let's say I applied the force for some amount of time t, then my velocity, let's say v1, will be equal to, let's say both were at rest initially, so this will be equal to a into t, and its velocity, let's say v2, will be equal to small a into t. So that means that this body will start moving with v2 in this direction and I'll start moving with v1 in this direction. So we just now learned that Newton's law does not only say that action and reaction forces F1 and F2 are equal in magnitude, F1 will be equal to F2, but they're opposite in direction. But it also says that they also act on different body. F1 is acting on body B and F2 is acting on body A. So acceleration of body A initially will be F2 over mass of the body A. Let's say this is A1, and acceleration of body 2 can be written as force on body 1, that is F1 over mass of body B. But let me try to mold this question a little bit. Let's say all of this is happening over some trolley. Let's say this is the ground and everything is frictionless, there's no friction anywhere. Now if he applies a force F on this object, the object will apply a force on the body. But if I ask the question, will this trolley move because of this force? We know that they both will move in opposite direction, but will the trolley move because of it? And the answer to this question is no, because you know Newton's first law. Newton's first law says that if a body is at rest, if you need to move it, then you need to apply some force on it, but that force has to be external force, and these forces are internal forces if you're talking about a trolley. So if you are interested in a trolley, then your system is trolley, and this man and this object both are parts of the system. So these forces are internal forces. And you can simply say that from Newton's first law, the trolley will not move. You can also understand it like this, that internal forces, they cancel each other when you're talking about a system. So when your system is this, then if this is F1 and this is F2, then you say F1 is equal to minus F2. But as box is also a part of the system, this F1 is a force on the system. And as man is also a part of the system, this F2 is also on the system. In this case, F net on the system turns out to be 0. So however you want to interpret it, but the answer is same, that the trolley will not move because of the force applied, because there is no external forces on the system. These are internal forces, and also internal forces cancel each other. So there is no net force on the system. So it's just like saying that, let's say your car broke down and you want to move your car. I'm not saying you're a monkey, but let's say monkey is driving a car and this car broke down. And let's also say that mechanic shop is just 100 meters away from him. So he just wants to push the car to that point. So he starts pushing it from being inside the car. So he started applying force on the steering wheel. Now will he be able to move the car? So the simple answer is no, he'll not, because these forces are internal forces. Because when I'm talking about whether the car will move or not, car is a system and I am also part of the car, steering wheel is also part of the car, internal forces will cancel each other out. Now let's say he calls a friend and he tells him to apply some force on the car. So this friend applies a force F on the car. Now will this force be able to move the car? And the obvious answer is yes, he'll be able to move the car, because this boy is not a part of the car. So when he applies force F on the car, this force is an external force, and external forces will move the body. Or in another sense, you can say that this F he applies is on the car, and car will also apply a force F on him, which will be used to move him in the backward direction, and the car will also move in forward direction. Now I'll tell you another misconception by asking a question. The question is pretty simple. Let's say Earth applies a force F on the moon. Now, if I ask you, how much force does the moon apply on the Earth? Is it greater than F? Is it less than F? Or is it equal to F? And the majority of answers I get is moon applies a lesser force on the Earth than Earth applies on the moon. And I think why people give this answer is because moon seems to be revolving around the Earth, not the other way around. So they think that moon must be applying a lesser force than Earth applies on the moon. But this is wrong, because we have Newton's laws. Newton's law says forces will be equal and opposite in direction. So force by the moon on the Earth, let's say it's on the center of the Earth. Let's say it's force on the Earth by the moon, and this is force on the moon by the Earth. You can safely say that magnitude of force of Earth on the moon will be equal to force of moon on the Earth. But this kind of breaks our intuition that then why it is the case that moon revolves around the Earth and not Earth revolves around the moon. And the simple answer is because same force does not mean same effect. Let's say I have a simple football and let's say I have a big iron ball. Now if I kick both of them by the same force F, will you think both of them will go by the same acceleration A? Will A1 be equal to A2? And the answer is no. A1 will be much larger than A2 because of inertia of these two balls. So same force does not mean same effect. Same force is applied on the moon, same force is applied on the Earth, but mass of the moon is comparatively much lesser than the Earth. For comparison, let's say mass of the moon is 1 kg and mass of the Earth is 100 kgs, and let's say force applied by both of them on each other is 10 newtons. Then in this case, acceleration of the moon will come out to be 10 over 1, that is 10. And acceleration of the Earth will turn out to be 10 over 100, that is 0.1 meter per second square. So who revolves around what? Moon revolves around the Earth and not the other way around. But it doesn't mean that moon does not have any effect on the Earth. In fact, if you go to higher classes, you'll see that on this line joining the center of these two bodies, there's a point about which both of them revolves, but that point lies inside the Earth. So Earth kind of wobbles because of moon's force on the Earth. This point we call it as center of mass, which you'll learn in higher classes. So I hope